Welcome back, my fellow developers. So, we are in chapter 6, which is designing with objects. Okay, so this chapter focuses on providing a guideline on how to design a system. Keep in mind that there is no wrong or right way to design a system, and do not get caught up on designing a perfect system. There will always be iterations, but it is best to keep the iterations to a minimum. The purpose of designing a system is catching as much bugs or problems before we even start programming. This is actually going to be a very simple lesson, so we're just going to go through this. Okay, design guidelines. There's a lot of design methodologies, and there is no one true methodology that triumphs over the other methodologies. The only important part of choosing a methodology is figuring out which methodology best fits your requirements, which methodology makes your team organization feel most comfortable, and which methodology will you and your team be able to stick with. There's a lot of different methodologies, but the best one is the one that you can follow and the one that you guys agree on and can actually implement. Okay, so generally a solid object-oriented design process includes the following steps. Doing the proper analysis. This is called object-oriented analysis. The users and developers must work hand in hand at all stages. During the analysis stage, they must do the proper research and analyze to determine the statement of work, the requirements of the project, and whether to actually do the project. If there is any red flags that scream out that the project should not be done, it is best to really take that into consideration and cancel the project. Step 2. Developing a statement of work that describes the system, otherwise known as SOW, the SOW. The SOW is a document that describes the system. The SOW gives the reader a complete understanding of the system. Regardless of how it is written, the SOW must represent the complete system and be clear about how the system will look and feel. At this point, the requirements might not be in final format. So this is basically just a description of what the system will be and what it will do. 3. Gathering the requirements from the statement of work. This is actually also called the software requirements specifications. We'll go into that in other lessons. The requirements documents describe what the user wants the system to do. The SRS documents will not be highly technical, but will include a clear list of requirements in specific detail. The SRS should be written in a way that allows users to get a very deep understanding on how the system will work, as well as provide guidance to the developers on how to create it. The SRS documents are highly important in the design and development of the system. Number 4, the development of prototype for the user interface. The main goal of creating a prototype is to allow the developers to get a feel and look at how the users are expecting the system to be. Having a good prototype can help immensely when identifying classes. Next is number 5, identifying the class. The best way to identify classes is to use the statement of work and highlight all the nouns. Pronouns and verbs may be attributes and methods. Take advantage of the fact that there will be multiple iterations and that the final result may look totally different from the initial design. Another thing I want to point out is that we will actually be covering how to do this and how to implement this when creating a structure for our programs, for our projects. So we'll dig a lot deeper into this. Number 6, determining the responsibilities of each class. Using the statement of work and the classes you have already identified, we must now determine the responsibilities of each class. Each class must contribute to the system and have a purpose. 7, determining how the various classes interact with each other. Only after knowing the purpose and main functionality of each class, we must determine how each class will work together to build the system. Determining how each class interacts with each other will help you separate interfaces and implementations. 8, creating a high-level model that describes the system to be built. After all the classes and their functionalities are determined, and after we know how all the classes will interact with each other, we can create a class model diagram using UML. The class model will show how the various classes interact within the system. Do not worry on this. We will cover how to create UML diagrams, including class models, use cases, activity diagrams, communication diagrams. For object-oriented development, a high-level model is a special interest. High-level models are created using the Unified Modeling Language, otherwise known as UML, and the goal is to create a high-level model that represents the system faithfully. High-level models make planning modifications easy without getting tangled up in the code. And that's the reason why I love architecture, because it clears the whole path and you get to see where you're going through. Okay, next is object wrappers and structured code. Okay, next is object wrappers and structured code. It is completely necessary to understand that object-oriented programming and structured programming work hand in hand. Even in object-oriented programming, structured code is used within methods. The object-oriented code that holds the structured object is considered the object wrapper. This concept is very important to prevent unstable systems due to outdated code or non-portable code. This is the awesome part about object wrappers. So I want to actually point this out. Or actually, I think the next one. Okay, last but not least, benefits of using object wrappers for structured code, existing code, or non-portable code. Using object wrappers for structured code, existing code, and or non-portable code allows us to use that code without completely depending on it. By using object wrappers, we are creating interfaces which allow us to change the implementation without having to make any further changes in the system. So basically what this means is that an object wrapper would be considered. Now, keep in mind, we are not focusing on the syntax, we are not focusing on keywords or anything. We're focusing mainly on the concept of object-oriented. So I will not write everything perfect. It is not the point here. So this will be the class. Or how about we just do method actually? We'll start with method. So this will be, let's say, public PVC, right? And then the code will go here, within here, right? I'm not sure if you can see that. I hope you can, okay? And then this would be a private, PRT, whatever, okay? Open, close, okay, whatever. Now, all our unmaintainable code, all our existing code that's from repositories or anything like that, and all of our structured code will go within here. So it could be, let's say, code for something that everybody loves, Internet Explorer 9, for example, right? Perfectly maintainable, right? It's, I swear, one of the I don't want to bash it, but we'll include this inside, and we're assuming that this is, of course, code for Internet Explorer 9, structured code, or even existing code, or non-portable, right? So we'll have this within a private method, private, but we will put it in the public. So it's only accessible through the public, right? So in case that we need to make changes to any, we gotta make changes to any code, as long as it returns the same output to the public interface, everything should work fine. Instead of having us to change this code everywhere, we only have to make sure that this has a similar output to the public interface, which would be implemented in other classes or other objects. So that is basically the advantage of object wrappers. And if you actually think about it, it's very, very powerful. Very, very powerful, especially when you're working with somebody else's code that's not yours, code that's basically structured and you don't know how it's gonna, if you're gonna move it, if you're gonna leave it alone, and even non-portable code, like code for Internet Explorer 9. So that's it for this one. I hope I see you guys next time.